Welcome to this e-learning module on inventory management in logistics and supply chain management. In the next part of our course, we'll focus on how companies plan, control, and improve inventory. Because inventory is not just stock on a shelf. It is cash, service capability, risk, and operational performance all at the same time. Let's get started. Here's what we will cover. First, we'll define inventory management and explain why it matters so much for cost, service, and competitiveness. Then we'll break inventory into its major types, like raw materials, work in process, and finished goods, because each behaves differently and must be managed differently. Next, we'll explore inventory control systems, from manual methods to barcodes, RFID, and real-time digital systems. After that, we'll move into optimization techniques such as EOQ, ABC analysis, just-in-time, vendor-managed inventory, safety stock optimization, and demand forecasting. We'll then look at the key metrics used to measure performance. Finally, we'll compare inventory practices across industries and review future technology trends shaping inventory management. We begin with the fundamentals: what inventory management is, and why it is essential in modern supply chains. The goal is not simply to reduce inventory or increase availability. The real challenge is balancing cost and service while operating in an environment full of uncertainty, changing demand, variable lead times, and disruptions. So, what is inventory management? Inventory management is the systematic approach to sourcing, storing, and selling inventory, covering both raw materials and finished goods, and everything in between. The core objective is straightforward but difficult to achieve in practice: having the right amount of inventory at the right time, in the right place, and at the right cost. Too much inventory increases carrying costs and ties up capital. Too little inventory increases stockouts, delays, and customer dissatisfaction. Inventory management exists to find and continuously adjust that balance. To do that, inventory management includes several key components working together. Demand forecasting estimates what customers will need and when. Inventory control decides how much to keep and when to reorder. Order management ensures customer orders are processed and fulfilled efficiently. Warehouse management focuses on how inventory is stored, handled, and picked. Supplier management ensures inbound flows are reliable and aligned with requirements. Inventory tracking provides visibility, ideally in real time, so people can trust the numbers. And finally, reporting and analytics turn data into decisions, helping managers identify problems early and optimize performance over time. Why is effective inventory management so important? Because it directly impacts financial results, operational stability, and customer experience. Optimizing inventory levels reduces cost, especially carrying costs like storage, insurance, and obsolescence. It improves cash flow by releasing money that would otherwise sit in slow-moving stock. It increases customer satisfaction by improving product availability and delivery performance. It strengthens operational efficiency by reducing firefighting, expediting, and last-minute changes. It enables better decision-making because reliable inventory data supports better planning. It can provide competitive advantage through faster delivery and better pricing, and it helps mitigate risk by building resilience against demand swings and supply disruptions. Inventory management has also evolved along with technology and business complexity. Traditionally, companies relied on manual record-keeping and periodic physical counts, slow, labor-intensive, and often inaccurate. In the 1970s and 80s, computerization improved record-keeping and basic planning. In the 1990s, ERP systems connected inventory data with purchasing, production, finance, and sales. In the 2000s, cloud-based solutions made inventory information more accessible across locations. And today, IoT sensors and artificial intelligence are enabling real-time tracking, predictive analytics, and faster, more automated decision-making. Even with better tools, inventory management remains challenging. Demand volatility makes forecasting difficult and increases the risk of either overstocking or stockouts. Global supply chains add complexity: more suppliers, more handoffs, longer lead times, and higher disruption exposure. Omnichannel fulfillment forces companies to coordinate inventory across stores, warehouses, and online channels. Product proliferation increases the number of SKUs, which complicates planning and increases the chance of slow movers. Sustainability concerns push companies to reduce waste, emissions, and overproduction while still maintaining service. Managing large volumes of inventory data requires strong systems and governance. And finally, integrating new technologies can be costly, complex, and disruptive if not managed carefully. Now let's move into Section 2. Types of inventory. Inventory is not a single category. Different inventory types exist for different reasons, appear at different points in the supply chain, and create different costs and risks. Understanding these differences is a foundation for any good inventory strategy. The first type is raw materials inventory. Raw materials are the basic components, parts, or substances used in manufacturing. Think of metals used in machining, ingredients used in food production, or electronic components used in devices. Raw materials must be available when production needs them, but holding too much raw material increases cost and can create waste if specifications change. Managing raw materials typically involves a few key strategies. Just-in-time ordering aims to reduce storage and carrying costs by bringing materials in only when needed. Strong supplier relationships are critical because reliable delivery and stable quality reduce the need to hold large buffers. Many firms also keep safety stock to protect production from supply disruptions. But raw materials come with challenges. Price volatility can affect purchasing decisions and budgets. Quality problems can stop production or create rework. And variable lead times make planning harder, especially when suppliers are overseas or capacity is tight. Next is work in process, or WIP, inventory. WIP includes partially completed goods that are somewhere in the production process. These items already have value added through labor, processing, and overhead, but they are not ready for sale. WIP is often a sign of flow. Some WIP is necessary, but too much WIP can indicate bottlenecks, inefficient scheduling, or quality issues. Managing WIP requires controlling the flow of production. Production scheduling helps sequence work to prevent unnecessary buildup. Lean manufacturing techniques, such as Kanban, limit WIP and make problems visible quickly. Bottleneck analysis identifies where capacity constraints cause queues, and cycle time reduction improves responsiveness and lowers the amount of inventory trapped in the system. Key challenges in WIP include valuing it accurately for accounting and tracking items as they move through multiple stages, especially in complex production environments. A third type is finished goods inventory, products that are fully completed and ready to be sold and shipped to customers. Finished goods have a direct and visible impact on customer service. If finished goods are not available when customers order, the business may lose sales, damage relationships, or create costly expedited shipments. Finished goods management relies heavily on demand forecasting because stocking decisions depend on expected sales. ABC analysis helps prioritize attention, ensuring high-value or high-impact items receive stricter control. Strategic safety stock protects service levels for key products. Inventory turnover optimization ensures products move efficiently and do not sit long enough to become obsolete. The major challenges here are fluctuating demand, which can quickly make a plan outdated, and product obsolescence, especially in industries like electronics, fashion, or seasonal goods. Another critical category is MRO inventory, maintenance, repair, and operating supplies. These items support operations but do not become part of the finished product. Examples include spare parts for machines, office supplies, lubricants, tools, and cleaning materials. Although each item may be low value, the impact of a missing critical spare part can be enormous, causing downtime and lost production. MRO inventory is often managed through practical control methods, min-max systems trigger replenishment automatically when inventory drops below a minimum level. Vendor-managed inventory can shift replenishment responsibility to suppliers for commonly used items. CMMS integration, using computerized maintenance management systems, connects spare parts inventory with maintenance schedules. Standardization reduces the number of unique items, simplifying stocking and reducing cost and complexity. Safety stock inventory is the buffer inventory held to protect against uncertainty. It exists because both demand and supply can vary. Safety stock decisions depend on demand variability, lead time variability, the target service level the business wants to achieve, and the trade-off between stockout costs and holding costs. The more unpredictable the environment, or the higher the service expectations, the more safety stock a company may need, but it comes at a cost. There are different ways to calculate safety stock. Some companies use simple fixed percentage rules, easy, but often inaccurate. More advanced methods use statistical formulas based on variability in demand and lead time, aligned with a desired service level. The most sophisticated approaches use advanced models that consider multiple variables and real operating constraints. No matter the method, safety stock should not be set and forget. It must be reviewed and updated as conditions change. Another important type is in-transit inventory, goods being transported between locations. This inventory is often overlooked because it is not physically inside a warehouse, yet it still ties up working capital and affects availability. It is also exposed to transportation risks, such as delays, damage, customs issues, and disruptions. Managing in-transit inventory depends on visibility and coordination. Real-time tracking technologies help companies know where goods are and when they will arrive. Transportation management systems support planning, execution, and monitoring of shipments. Integrated supply chain visibility connects transportation status to inventory systems so planners can make better decisions. And lead time optimization, such as faster modes, better routing, or improved customs processes, can reduce the amount of inventory stuck in transit. We now move to Section 3, Inventory Control Systems. These are the processes and technologies used to record inventory, track movements, and maintain appropriate stock levels. The right control system increases accuracy, reduces labor, improves responsiveness, and supports better planning. Manual inventory systems rely on physical counts and paper records. They can be simple to start and low in upfront cost, which is why very small businesses sometimes still use them. But manual systems are time-consuming, prone to human error, and difficult to scale. As SKU counts grow and customer expectations increase, manual tracking becomes a major limitation. Barcode systems represent a major step forward. A barcode is an optical, machine-readable representation of data. Barcode systems require barcode labels, scanners, and software connected to databases. By scanning items during receiving, picking, and shipping, companies capture movements quickly and consistently. The benefits of barcode systems are significant. Accuracy improves because scanning reduces manual entry errors. Data entry becomes faster, lowering labor time per transaction. Labor costs decline as processes become more efficient. And barcodes integrate relatively easily with warehouse systems, ERP platforms, and shipping solutions. For many organizations, barcodes provide a strong balance between cost and capability. RFID systems, radio frequency identification, go even further. RFID uses radio waves to identify and track items. The key advantage is that RFID does not require line of sight like barcodes. Tags can be read through packaging, and multiple items can be scanned simultaneously, which is especially valuable in high-volume environments. RFID offers greater data storage capacity, real-time tracking potential, and durable tags depending on the application. However, RFID also comes with challenges, higher implementation costs, and potential interference issues, especially around metal and liquids. Successful RFID use requires careful testing, thoughtful tag placement, secure data handling, and good training, so operations teams trust and use the system properly. Computerized inventory systems include everything from spreadsheets to advanced ERP modules. These systems can support real-time tracking, automated reordering, embedded demand forecasting tools, and integration with purchasing, sales, finance, and production. The value comes not just from storing inventory quantities, but from connecting inventory decisions to the broader business. With computerized systems, accuracy improves through standardized transactions and controlled processes. Real-time visibility supports faster decisions and better service. Advanced analytics can identify trends, slow movers, and root causes of inventory issues. And scalability allows the system to grow with the business, across more SKUs, more warehouses, and more channels. Perpetual inventory systems continuously update inventory records as transactions occur: receipts, picks, returns, transfers, and shipments. Instead of waiting for a monthly or quarterly count to update records, the system reflects changes immediately, giving managers an up-to-date view. This creates several benefits. Real-time information supports better replenishment decisions and fewer surprises. The need for full physical counts is reduced, though not eliminated, because the system already tracks changes continuously. Turnover can improve because replenishment becomes more accurate, and stockout prevention becomes more proactive, with alerts and reorder notifications triggered automatically. Periodic inventory systems update records only at set intervals, typically using physical counts. They are simpler and less dependent on technology, but they do not provide accurate real-time information. That increases the risk of running out of stock unexpectedly, especially when demand is volatile or lead times are uncertain. Choosing the right inventory control system depends on business size, inventory complexity, technology capabilities, and budget constraints. A small operation with few SKUs may succeed with a simpler system, while a large omnichannel business needs real-time integration. Many companies adopt hybrid approaches, combining, for example, perpetual tracking in key locations with periodic audits for verification. Next is Section 4, Inventory Optimization Techniques. Optimization is the discipline of balancing inventory cost with customer service. The goal is not minimum inventory at any cost, but optimal inventory given service targets, uncertainty, and operational constraints. A classic technique is economic order quantity, or EOQ. EOQ identifies the order quantity that minimizes the total cost of ordering and holding inventory. The formula is EOQ equals the square root of 2 times annual demand times the fixed cost per order, divided by annual holding cost per unit. In the formula, D is annual demand, S is fixed cost per order, and H is annual holding cost per unit. EOQ is useful because it provides a structured way to think about order frequency and lot sizes. EOQ has clear advantages. It is simple to calculate, easy to understand, and provides straightforward ordering guidelines. But it has important limitations. It assumes constant demand and stable conditions, which is rarely true in real supply chains. It also doesn't include quantity discounts, or many real-world constraints like minimum order quantities, capacity limits, or variable lead times. So EOQ is best viewed as a starting point, useful for insight, but often adjusted in practice. ABC analysis is another widely used optimization approach. It categorizes inventory based on value and importance. A items are high value and typically represent a small percentage of items, but a large percentage of total value, often described as 20% of items representing 80% of value. B items are moderate value. C items are low value and usually numerous but less critical financially. This method helps organizations focus effort where it matters most. Implementing ABC analysis follows a clear process. First, calculate annual usage value for each item, often unit cost multiplied by annual demand. Next, rank items from highest to lowest value. Then assign categories, A, B, and C, based on cumulative value contribution. Finally, create different management approaches, tight controls and frequent review for A items, moderate controls for B items, and simpler, low-cost controls for C items. Just-in-time, or JIT, is a strategy aimed at reducing inventory by receiving goods only as they are needed, especially in production. JIT is built on principles such as minimizing waste, reducing holding costs, improving process efficiency, and enhancing quality. In a strong JIT environment, problems become visible quickly because there is less inventory to hide inefficiencies. The benefits of JIT include lower inventory carrying costs and improved cash flow, since less money is tied up in stock. However, the risks are real. JIT requires reliable suppliers, stable transportation, and disciplined internal processes. When disruptions occur, supplier failures, transportation delays, or sudden demand spikes, low inventory buffers can translate into immediate shortages. Many organizations today pursue a more balanced approach. Lean where appropriate, but resilient where necessary. Vendor-managed inventory, or VMI, is a collaborative model where suppliers take responsibility for maintaining the buyer's inventory levels, typically using shared demand and inventory data. VMI can reduce inventory costs, improve visibility across the supply chain, and lower administrative workload for the buyer because replenishment decisions are partially transferred to the supplier. For VMI to succeed, a few conditions must be in place. Trust between parties is essential because data sharing and joint decision-making require cooperation. Sophisticated IT systems are often needed to exchange accurate, timely information. Performance metrics must be clearly defined so both sides know what success looks like, such as service levels, stock-out rates, and inventory turns. Transparent data sharing is critical. Without reliable data, the supplier cannot manage inventory effectively. Safety stock optimization is the process of determining the right buffer inventory level, not too high and not too low. The decision depends on demand variability, lead time variability, service level targets, and overall cost considerations. For example, a life-saving medical product may require a very high service level and therefore more safety stock, while a low-margin item may not justify high buffers. There are multiple methods to set safety stock. Simple approaches use fixed percentages, which are easy, but may ignore true variability. Statistical models incorporate variability and desired service levels, often providing a better balance. More complex models consider multiple variables and network-wide effects, especially in multi-echelon supply chains. The key point is that safety stock should be reviewed regularly, because variability, lead times, and service expectations change over time. Demand forecasting is fundamental to inventory optimization. If forecasts are consistently wrong, replenishment and production plans will be wrong too. Forecasting methods include time series analysis, such as moving averages and exponential smoothing, causal methods like regression and machine learning, which link demand to drivers, and qualitative methods such as expert judgment, market research, and customer input, especially when data is limited. High-quality forecasting requires several ingredients. You need reliable historical data, clean, consistent, and relevant. You must account for seasonality and trends, so patterns are not mistaken for randomness. Forecast accuracy should be measured continuously using error metrics, and models should be updated regularly as patterns shift. Finally, strong forecasting often combines data models with market intelligence, because real-world events, promotions, competitor actions, and macroeconomic changes can shift demand faster than historical data alone suggests. In Section 5, we focus on performance metrics. What gets measured gets managed. Metrics help organizations evaluate efficiency, effectiveness, and the financial impact of inventory decisions. They also support benchmarking, continuous improvement, and alignment across departments. Inventory turnover ratio measures how many times inventory is sold and replaced over a period. The formula is cost of goods sold divided by average inventory. In general, higher turnover indicates more efficient inventory management, but extremely high turnover can also be a warning sign if inventory is too lean and stockouts are frequent. Low turnover may signal overstocking, slow-moving items, or obsolescence risk. Days Sales of Inventory, or DSI, measures how long it takes to sell inventory. It is calculated as average inventory divided by cost of goods sold, multiplied by 365. A lower DSI typically suggests better efficiency, but again, it should be evaluated relative to product type and industry norms. For example, perishable goods should have very low DSI, while slow-moving capital goods may naturally have higher DSI. The stock-to-sales ratio compares the value of inventory on hand to the value of sales. This ratio is useful for monitoring trends over time. If stock-to-sales rises, it may indicate demand is slowing, forecasting is off, or replenishment is too aggressive. If it falls too low, it may signal a risk of stockouts or insufficient preparation for demand peaks.